Hello everyone. Good morning. Welcome to Mohansh Technologies. So long back we discussed about quantum computing, right? So the time came. Very soon we are going to be starting batch for quantum computing. So I already told you guys what is the difference between the regular classical computing and quantum computing. Classical computing is going to be working with the binary values like zeros and ones, but quantum computing is not working like zeros and ones. It is something like a superposition. So what is the state between the 0 and 1? The kind of superposition it is going to be working, we already know that. So one more time, if anybody not watched the previous videos, just try to observe what is classical computing and what are the computers which are going to be working with the classical computers. So, all the CPUs and GPUs are classical computers. That central processing units and graphical processing units. Those are working for the classical computers. And in classical computing, you will be having binary values. Okay. How the system is going to be understanding the machine learning, the machine code, what the machine code is going to be working with the binary values 0, comma 1. You know that the machine code is going to be something like 0 and 1 in the classical computing. We know that. Everybody know that machine code is zeros and ones. But in quantum computing, it is not like that. In quantum computing, there is a concept called QPU, quantum processing unit. What this quantum processing unit is, something like a qubits. Okay, you will be working with the qubits here. Qubit is something like a quantum bit. Qubit is something like a quantum bit. Okay, now I want to tell you what is this quantum bit is. What is this quantum bit is? So there is a 0, there is a 1. There is a 0, there is a 1. So for example, here we have two states, like clearly we have two states. Clearly 0 is the state. Clearly 0 is the state. But 1 is also a state. A system have two states here. Okay, a machine have two binary states here. That one is a 0 and one is the 1. 0 state is there, 1 state is there. But in the quantum computers, there is a position between the 0 and 1. There is a position between the 0 and 1. There is a position between the 0 and 1. There is a state between the 0 and 1. So 0 is the state, okay, fine. 0 is the state, that is the state, and 1 is the state. 1 is also one state. And I want to define one more state between the 0 and 1. Okay, what this kind of state is? What is this kind of state is? That quantum computer is going to be understanding. So that kind of state is a little bit, I want to draw the thing. Okay, let me draw the thing. Okay, there is a state between the 0 and 1. Let me take some, 1 second, give me some time. Yeah, this is bigger. This is okay. Hmm. There is a state between the 0 and 1. Here I try to give the fresh. Okay, there is a state between the 0 and 1. Between the 0 and 1, there is another state is available. Okay, this kind of state is called superposition. This kind of state is called superposition. Okay, I will give you one simple general example for this. I will give you one simple general example. So there is a coin. There is a coin. When you flip the coin, so here also I'm taking the coin, and here also I'm taking the coin. Here I'm taking the coin, and when you flip the coin, guys, when you flip the coin, when you flip the coin, it may get a state called head, or it may get a state called tail. Head means 1, head means 1, tail means 0. Head means 1, tail means 0. Coin state. For example, you take a example, general example, a coin state. When you flip the coin, there are two states. One is the 0, one is the 1. 0 and 1. So the coin have some position. When you flip the coin, it may be tail. When you flip the coin, a probability of the coin is 0 or 1. Here, the probability of the coin, when you flip the coin in the quantum gates, when you flip the coin in the quantum gates, the position is completely different. It is not 0 and 1. It is not 0 and 1. It is not head and tail. So when you flip the coin is flipping like this. So when you flip the coin, okay, when you flip the coin, so coin is flipping and coin is flipping, flipping, flipping. And the state, in the flipping state, Okay, when you throw the coin in the air, the coin is flipping, right? In the air, the coin is flipping. In the air, the coin is flipping. In the flipping also, you will be having one state. This flipping state is available. The flipping state is available. That flipping state is superposition. The flipping state is superposition. But here, it may be the coin is head or tail. Here we have two states only. Finally, we have the two states. The coin have two states. It may be, sometime it may be head, sometime it may be tail. Okay. But here there is a state, a flipping state. This is actually a state called flipping state. A flipping state, quantum computing have the superposition. This is flipping state. Flipping state. Okay, let me try to give you a general example. This is a general example how the quantum computing is working. How the quantum computing working. Flipping state. A coin is going to be having another state. That state is actually quantum state. So I already drawn the thing. State 0, state 1. Between the 0 and 1, there is another state. That kind of probability state quantum computing is going to be estimating. And based on that, your computer is working in the real time. And this quantum computing, when this quantum computing comes into the picture, when the computers are going to be generating with the qubits, then obviously your uh, computing performance is super high speed. Super high speed. For example, in the general computing, there is a data analytics. There is a data analytics they have to do. Okay, for the data analytics, general computer or GPUs or CPUs are working like a 2 years time, 1 year time, or 1.5 year time. But the quantum computing, which is going to be solved within 2 seconds, that kind of solution, computing gives within 1 to 2 seconds. Okay, so there is a encrypt algorithm, encryption algorithm, whatever it may be. For example, there is a 256 256 encryption algorithm which is going to be available. So normal computer will take to decrypt it 2 years or 1 year time. The same computer, quantum computer will take just like 2 seconds or 3 seconds to decrypt the encryption. Okay, so that kind of performance, that kind of high performance, which is going to be available in the quantum computing, and now quantum computing is going to be developing by different companies. Okay, Google is developing, and uh, uh, IBM is developing, and some other companies also going to be developing this quantum computing. Even Microsoft also involved to develop the quantum computers. So let me go and show the things like a quantum computing, how the quantum computing is available. Quantum computing is an advanced field that uses the quantum mechanics principles, superposition, entanglement. So this entanglement is the kind of relation between the qubit to qubit. Okay, so that entanglement is going to be there by using the quantum bits or qubits. That is going to be having different use cases to solve the complex problems exponentially faster than classical computer. So impacting areas like medicine, artificial intelligence, and cybersecurity. These are the major important things. These are the major important areas where the quantum computing is going to be hitting the market. In the part of medicine, in the part of the artificial intelligence, a part of the cybersecurity, which is going to be giving a very huge in demand. So uses of the quantum computing mechanics, superposition, entanglement, and processing power. Potential application, there are different kind of potential applications which are going to be involved in future. Drug discovery and medicine, and artificial intelligence, optimization, cybersecurity, and scientific research. Okay, simulation, complex physical systems, and phenomena that are impossible to study with the classical computers. Okay, whatever impossible things in IT industry, that impossible makes possible by the quantum computing. Okay, so current status, emerging technology, building blocks, and future potential. There are multiple different kind of things. And let me show IBM. IBM quantum computing. Yes, our classes are going to be working with IBM quantum computing like a QISKit framework. Anyway, we have to go with the QISKit framework. Okay, so what is quantum computing? Physical applications of quantum computing, practical applications, and how quantum computing work, quantum computing components, and classical computing versus quantum computing. When quantum computing superior, quantum computing use cases. There are different theory which is going to be available in IBM. You can search for it. Let me search for QuizKit here. There is a library, there is a framework called QuizKit. Okay, quantum computing implementing with the QuizKit framework. Okay, that I want to execute for you. I want to show for you now. QuizKit. Wait for 1 second. It is searching for that. Okay, IBM QuizKit. Okay, yeah, QuizKit. QuizKit is the world's most popular and performant software stack for quantum computing and algorithms research. Build, optimize, and execute the quantum workloads at scale. So we will be having the installation process in the coming days. So how the QuizKit is going to be available? Already 13 million QuizKit downloads available. Already 13 million people downloaded already QuizKit. Open source. Yeah, that is a very interesting thing. They are not actually charging money for the quantum computing QuizKit. Open source quantum software to large scale executions. You can download free of cost, and it is actually worked with multiple layers. QuizKit have multiple layers. QuizKit quantum. Let me draw the things. Okay, QuizKit have some one layer, quantum information science and heterogeneous architecture. So QRMI, okay, so Slum plugin and QuizKit services, serverless, and quantum hardware plugins, all these things are available. And algorithm development, this is the important case where you are writing the Python code. QuizKit add-ons, QuizKit function templates. So these are the topics we are going to be working on coming classes and how this QuizKit is working. But when you want to come to the QuizKit, definitely you need to understand Python programming. So already we have the Python programs or Python programming videos in Mohansh Technologies YouTube channel. You just go through the Python programming videos first. When you know Python, then QuizKit learning is very simple. Quantum computing learning also very simple. I already told you, not only Python. Python is not only the knowledge you have to understand quantum computing. Maths also very important. So maths like linear algebra, vectors, probability. So that kind of mathematics also very important to understand the quantum computing subject. So Mohan's Technologies is going to be providing you basic requirements for the quantum computing. So Python already videos are available even for the mathematics, linear algebra, calculus, and kind of vectors and probability, whatever it may be required. Those videos also I will upload. And these are the prerequisites. These two are prerequisites to understand the quantum computing or QuizKit. And a huge number of jobs which are already available for the quantum computing. People are recruiting. People are recruiting. Definitely. People are recruiting. If you want to see, I will show. People are recruiting for the quantum computing, and this is going to be available for the next 30, 40 years in the industry. All the technologies are coming and going, but quantum computing is going to be coming. People are already started research on quantum computing. They are trying to implementing their own qubits in the companies. So people are recruiting for quantum computing. So let me show quantum computing, Python QuizKit, quantum computing, QuizKit and Python. Let me show how many number of jobs which are available for the quantum computing. Okay, so this is not a right search. Where you have to search for. Let me go for 1 second. Jobs. Search properly. Quantum computing. And yeah, you can see when I search for quantum computing, how many number of jobs which are available? 6,867 already openings are there. In Naukri, I am searching for the quantum computing. You will be finding a number of jobs. Not only quantum computing, let me search for QuizKit also. QuizKit. QuizKit. This one, QuizKit. Okay, so 14,485. Okay, let me have the Python also. If I insert Python developer, QuizKit Python, you will be finding 29,000. See, knowledge is when you are trying to providing the different knowledge here, quantum computing, QuizKit, and Python, you will be having huge number of job openings. Let me open in the LinkedIn also. In the LinkedIn, even in the LinkedIn, I go for the jobs area and search for the quantum computing. Search for the quantum computing. So quantum computing and QuizKit Python one by one. Okay, all the keywords you have to keep. Quantum computing, QuizKit Python. Yeah, search for that. Huge number of job openings. Quantum developer. What quantum developer? What is the job role? What is the job role for the quantum developer? So strong understanding the quantum mechanics and quantum computing principles, proficiency in Python and numerical libraries. Experience in quantum frameworks, SDKs like QuizKit and Pennylen, and immense experience with the classical algorithms, optimization techniques. Hands-on experience with the modeling, solving the optimization problems, various solvers. See, guys, you will be having you will be having huge number of job openings. You will be having huge number of job openings for the quantum computing, but nobody knows about this technology. Nobody knows about this technology. Some people are actually getting fear when a word called quantum computing. What is this? This is maybe uh, this is some kind of scientific this is something like rocket science. This is something like rocket science. People are actually feeling. Don't feel like that. Quantum computing is very easy, very easy when you know Python very well, when you know mathematics very well, you can able to easily understand quantum computing. So a lot of calls actually we are getting, sir, I want to learn quantum computing, but I don't know Python, I don't know mathematics. Then I told them Python is simple, maths also very simple. You learn Python and maths like a kid, then you try to learn the subject in the quantum computing, then you try to reach your job. 100% you can able to reach your job. And this is going to be an emerging technology. Even governments also supporting for that. Governments also releasing the funds for the quantum computing development. In Amaravati, Chandrababu Naidu garu also started the quantum valley kind of thing. And Narendra Modi ji also giving a lot of funds, uh, crores, thousands of crores, Modi garu actually investing for the quantum computing development in India. Already US people are not going for US now. People are coming to the India only. So in India, in the next level, the quantum systems are going to be generating, and you people come and learn quantum computing with Mohansh Technologies. Come to the Mohansh Technologies agenda is different. We are available in only online platform. We are not teaching in offline. And one more important point I want to tell you guys. Outside for quantum computing, if you inquire, people are actually charging like 2 lakh, 3 lakh, 3 lakh minimum, 3.5 lakh. I also inquired. I also inquired for quantum computing. They are actually telling like a 3.5 lakh, 4 lakh for 1 year. 1 year course, 3.5 lakh, 4 lakhs. They're actually charging, and no organizations are going to be dealing the quantum computing in these areas. But Mohan's Technologies got ready to give the delivery of the quantum computing subject for the people with less price, very less price, very less price. We have to go with the foundations, quantum foundations, programming tools, quantum algorithms, mathematics for quantum computing, how the quantum hardware is working, and applications. What are the different kind of applications we have to build up, and the career industry readiness, and tip for the website placement. See, there are multiple key skills we have to go with. And what is the week one we are going to be discussing with? In week one, we are going to be discussing with the uh, quantum and Python basics. What is quantum and how the Python will be, and introduction to the quantum computing, QISKit installation, classical versus quantum computing concepts, qubits and superposition, and quantum gates like XYZ, Hadamard, Python coding, how Python code will be there for this quantum gates finding, and measurements of the probabilities, and Bloch sphere visualization, and mini project, coin toss. I already given the coin toss example, right? The same coin toss example, mini project we will do. And week two, multi-qubit systems and entanglement, multi-qubit circuits in QISKit, entanglement and C0 gate implementation, Bell states like coding and simulation, quantum interface experiments with QISKit, quantum interpolation concepts, lab implementation, and mini project also we have to keep. And week 3, quantum algorithms introduction and discharge algorithm, lab, and Grover's algorithm, lab, Simon's algorithm, lab, mini project. Yes, we will be having a week 4, Shor's algorithm, this quantum Fourier transformations and lab, Shor's algorithm, factorization theory, lab, Shor's algorithm simulation, RSA quantum cryptography impact, quantum phase estimation with the question. Mini project again. Okay, week 5, quantum machine learning. This is a very impact. Already artificial intelligence is there. Already generative AI is there. Already agentic AI is there. But all this artificial intelligence under the quantum computing again. All these artificial intelligence techniques under the quantum computing again. Quantum computing have some machine learning algorithms again. Introduction to quantum machine learning, QML algorithm. There are multiple QML algorithms we are going to be learning. Encoding classical data into the quantum states and uh, variational quantum circuits and variational quantum again solver, quantum support vector machines, train a quantum classifier with QISKit ML mini project. Advanced applications like quantum approximate optimization algorithm and labs. Every concept we have the lab, sir. Lab is important here. Theory is theory. Yes, theory compulsory we need to understand. Then lab is also very important. And finally, week 7, industry use cases like how quantum computing use cases in the finance and healthcare, and cloud quantum platforms. What are the different kind of cloud platforms which are available? And there is a big project, capstone project. We have to deal with the quantum computing. These are the things Mohansh Technologies is going to be providing you, and Mohansh Technologies is having already emerging technologies. We are not actually giving like a Python, this just like C, C++, MS Office, this Tableau, Power BI. Still, people are actually sitting with the old area or what is this called? Hmm? Gone area. People are not using the button phones now. People are using the touch phones now. And in future, people are using different kind of phones also. In that way, technologies are emerging. The same time, you people also need to be emerged and come and learn with the quantum computing. Very soon, we are going to be start the batch. Please visit Mohan's Technologies. If you like the video, please share with your friends. Subscribe the channel. All the best. We'll meet soon in the quantum classes. And please watch the different videos in the Mohan's Technologies. Mohan's Technologies have different kind of playlist here. Mohan's Technologies YouTube channel have a playlist here. Go to the playlist. You will be finding a different kind of playlist here. Okay, I have Python videos already uploaded, 29 videos, and live classes, 2 live classes are going. One HTML UI free, that is Monday to Saturday, and one more free Python already going Monday to Saturday. If you don't know about it, just inquire Mohan's Technologies. They will provide the link for you. At the same time, October 20, on October 20, we are going to be starting a new batch for October 20. We are going to be starting a new batch for free full stack Python, full stack ML AI, full stack ML AI, and this is going to be a 45-day session free of cost. No need to pay for money. And there is a one more free batch. There is a one more free batch. The same day, one more free batch we are going to be starting. That is a free Marn stack. Free Marn stack. Marn, you know, right? Marn stack, you know. MongoDB Express React Node. That is also integrating with ML AI. That is also integrating with ML AI. These two batches on October 20, we are going to be starting. If anybody want to learn, you please enroll for that. I will give you the links in the description box, group links. You people can join for that. And all the best, guys. All the best for your future. Everybody want to get the job. That is the Mohan's agenda. And this quantum computing also will go for 45 to 50 days. The session is every day 1.5 hour session. And you people come to online and learn happily with less price. We don't want lakhs of rupees like other institutions, other organizations are taking. That's all what actually I want to tell you guys. Please like the video, share the video, subscribe the channel. If anybody not subscribed so far, please subscribe the channel. Please click on the bell icon. This is what actually I want to tell about the quantum computing one more time. Anybody newly watching the Mohansh Technologies videos or Mohansh Technologies channel, please share this video for your friends and like the video, subscribe the channel. Thank you. See you signing off. We'll meet again coming sessions in the quantum computing. Bye for now.